Okay, that's a class. They usually clap for me every time. Anyway, so dosage D, this is a direct inverse variation question. Something varies directly. That's going to follow in the book we said y equals k times x. In this case, it's dosage varies directly as mass, so that's going to be dosage equals k times m. All right, and then you have to solve for k. At one point we had k equal to 1. If k is 1, I'll tell you. All right, it's kind of sneaky, so I won't try and trick you. Okay, so we solve for k here. That means in the question it says, I think it's kind of cut off on here, but if a patient weighs 200 kilograms, or actually what was let's see here, move over. 200 milligram dose when a patient weighs 50 kilograms. That's what it was. So 200 milligrams equals k times 50. This is just a very simple, fun little math book problem. It's going to work out to be 4. So once you find your k, then you can write it in. Now you can make like your formula here. So you'd say like dosage equals 4 times the mass. All right, and then the next follow-up question says, well, what is the dosage of a person with a mass of 70? Well, we got a formula for that. It's 4 times, what was it, 70, whatever the mass of the person. So 70 kilograms is 4. That'd be 280 milligrams. Okay, so there we had direct inverse variation. If it was inverse variation, if, this problem isn't inverse, but if it was inverse, remember that is y equals k, divide by x, and then you end up doing the same thing, but it's divide. So those are kind of the two things that you want to make sure you have. Is there's your kind of inverse variation, and then here's your direct variation, and so there you go on that. All right. Another big part of this chapter was multiplying, dividing, adding, subtracting rational expressions. I call them polynomial fractions on steroids. Okay. So what we want to do before you multiply this stuff is factor it, and then you can simplify before you multiply. You don't want to get too big of a product if you don't have to. So factor everything. Factor a 3 out of there, x minus 4. See what I can factor. Denominator. Warning. This is the difference of squares. Okay? How do you factor the difference of squares? One's plus, one's minus. Don't forget, so a lot of people just put x minus 2, or something like that. Okay, let's do this one up here in red, x minus 2. Oh, that doesn't do anything. Let's not do that. Let's do this one on the bottom, x minus, I said red, x plus 4, x minus 4, there. So we kind of factor everything that we can. That's over x minus 2. That's in parentheses. Remember, you can only cancel out factors, so they have to be multiplied. Stuff has to be multiplied in order for you to get rid of it. So like here I have an extra x minus 4 in the top and bottom. I have an extra x minus 2 here and here. And so what's remaining then would be the product, which is 3 over x plus 2 times x plus 4. Just like that. And then we had restrictions on our domain because the denominator cannot be what class?
Negative.
No, the denominator can be negative. That's okay. I must not have done a good enough job teaching. Let's go to someone else. 0. Okay, 0. He got it. Okay, good. So it can't be 0. So if it can't be 0, then this cannot equal what? Negative 2 or negative 4. And then you also have to look at all of the denominators. So you have to look up here at like all these denominators. Are there any other restrictions? Because just because we canceled them out doesn't mean that it wouldn't make a denominator 0. So it can't be 4 either. Whew, it can't be 4 either, or it also can't be positive 2. So plus or minus 2 or 4 cannot be restricted domains. All right. Same type of problem in number 3, but the only real difference is that dividing is the same as, let's check. Dividing is the same as what? She didn't want to say anything. Dividing is Dividing is the same as?
Multiplying by the reciprocal.
Okay, she fumbled a little bit through the words there, but she was good job participating. Way to go. All right, so now we basically just take this, flip that around, and do the same thing that we just did, right? Okay, so I'm going to pause, go really fast, and then you'll be able to do that real quick. Okay, here we go. All right, jumped ahead a little bit, got this thing in factored form, and so now we can find our common factors here. So it looks like we have an extra x plus 1 here, x plus 1 there, x minus 2 here, x minus 2 there. What's left when we have this? What's left? Anything in the numerator? There's nothing left in the numerator. What do we do? What is there always left? 1. There's always left a 1. So that's a 1 over, and then we got 3 times x minus 3. Okay, good. And then don't forget about your restrictions, blah, 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 yada, yada, yada. Okay, next problem. Jump to question number 4. We have common denominators here, and we're adding fractions. We have common denominators. That's good because you need common denominators, so we already have common denominators. So when you add a fraction, you keep the denominator the same. So everything in this case is going to be added and put over 2x plus 5. So in that case, then, what is x minus 1 plus 3x plus 4? What do you get when you add those two together? All right, well, how many x's? We got x minus 1 plus 3x, so that's going to be 4x. And then it's going to be minus 1 plus 4 is plus 3, right? Okay, and can anything reduce? Hey, warning. This is a super common mistake I see people do. They go, oh, look, I got a 4x and a 2x. Dude, I can just do that and make that a 2. No, you can't do that. You can't do that. You can't do that. You can't do that. And there's no back button on here, so that's kind of annoying. So now I have to erase that stuff. Pause. Okay, so really we can't do anything with this. There's nothing to reduce there. Final answer. 4x plus 3 over 2x plus 5. Of course, you have your restrictions, yada, yada, blah, 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 blah. Okay, here we go. Next one, minus. All right, watch out. This minus can be a little tricky. And we do not have common denominators here, do we? We do not. So what happens is we have to get a common denominator. And this is kind of nice. They factored this left side for us. So now I just noticed, it's this happy little problem. I just noticed that over here, I'm just missing a factor of x plus 2. That's it. Just missing a little happy factor of x plus 2 over there. Okay. So now I'm just going to clean that up a little bit. And we're going to go with 2x plus 8 minus, now this is another warning, warning, minus, and then I have to, of course, distribute this. This is going to be minus 3x plus 6. You have to minus the whole thing, which means you have to minus that stuff, and you have to minus that stuff. Now be careful. Be careful on that. Okay? And then, of course, it's all over my common denominator, which just leave it in factored form. What did I say? Just leave it in factored form. It's fine. You don't have to multiply that out. Just leave it. Okay, so what is 2x minus 3x minus 6? 2x minus 3x is minus x. All right, and plus 8 minus 6 is plus 2. And that's all over x minus 4x plus 2. Oh boy, I'm so glad that we could look at this together, right? Minus, I think I am done. I don't know. I like what you're thinking, and I actually thought the same thing first, but then I don't. You can't just, if you take a negative 1 out of here, then you're going to be left with x minus 2, and it's not going to. So it's actually, I was thinking the same thing. So good job. Like medium minds think alike or whatever, but that's not going to work out there. Okay. All right. Having fun? Number 6, they call this a complex fraction. Whoa. Crazy. Dude, fraction over a fraction. Are you kidding? This is crazy wicked. All right, really it's just divide, all right? Just calm down. It's just divide. See this little deal right here, this thing? See that thing right there? That's just divide. And we know that divide is the same as?
Multiplying by the reciprocal.
Yep. All right, did you hear it? Okay. She got a little nervous there, but yep. All right, so now it's multiplying by the reciprocal. So I'm just going to set this one up. I'm not going to finish it. X plus 2 over 2 is the same as, now divide, but instead of divide, I'm going to multiply. And then I'm going to take the reciprocal of this one. So instead of dividing by that one, I'm going to take the reciprocal of that one, which means I'm going to have the 2x minus 8 on top. Woo! Really talking faster. And then the x squared minus 4 on the bottom, like that, see? So I just take this denominator, I flip it, and I multiply it by the numerator. That's all that's going on there. Whoa, crazy complex fractions. It's really not that complex. You just can't be scared just by looking at it. You can't just look at that and just get scared and just quit. That's the problem. That's what people do. All right, so now I told you that I wasn't going to solve this one, but I lied a little bit because I think it's fun to solve. So then we factor that, factor this. What reduces? Ooh, looks like we got this reducing. Oh, and a 2. What's left on bottom? X minus 2. What's left on top? X minus 4. So that's going to be X minus 4 over X minus 2. Okay, and then don't forget your restrictions or whatever. Oh, but Mr. Bolio, can I cancel those X's out? No, Jim, you can't. Okay, remember, that's like a whole thing there. X minus 2, that's in parentheses. You can't just cancel those X's out. That's illegal. All right, that brings us to number 7, my favorite problem. This is a resting problem. So what you need to do here is take a few deep breaths, okay? In through the nose, out through the mouth. I think that's a... Everything will be okay. Everything will be okay. And that's what you have to say that at the end. Everything will be okay. All right. That's 20 seconds of your life you'll never get back, right? That's what they say. Do you know what to do when an exponent is a fraction? Do you know what to do when an exponent is a fraction? All right, well, change it. Change it to radical form. See if you can understand it a little bit. This is the same as x. There's some sort of root, x, to like what power, and then like that. And then we could change it to radical form. Do you remember which one the denominator is? Is it the radical index, or is it this one up to the whatever power? Ding, 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 you're right. It's this one. Okay, so this is the 5th root of x squared. That's what that is. That's how it works. So this next one, this is a happy little math book problem right here. You guys are going to get a bang out of this one. All right? So what happens here is it's like, hey, Jim, I got the 3rd root of 8 squared. You know what that is? That's 2 squared, because the 3rd root of is 2. I'm having some technical difficulties here. So, oops, I didn't mean to draw that. Sorry, guys. See what it's like being in my class? It's difficult. It's difficult. So that's 4. I've been making up this joke forever. Next year, lacrosse, on one of the lacrosse games, let's get radical night or day, and you get alternate jerseys, and all the jerseys will be like, instead of number 4, you'd have 8 to the 2/3 power. They'd all be in fractions. It'd be a fun day. You know, it'd be a fundraiser or something. People auction those things off. People will buy them. They'll be cool. Yes, they will buy them. Why wouldn't they buy them? All right. Next one over here. What do we have here? Cube root of x to the 5th. Can I pull out any perfect cubes there? Yes, I can. There's one in there. Look at. Geez, listen to these students. They must not be listening to me. Cube root of x cubed times the cube root of x squared, right? Because x squared times x cubed is x to the 5th, right? Okay, so how many perfect cubes are in there? 1. All right, after we've done this enough, we start looking at this and we go, oh, well, as long as that is bigger than that, there's going to be some perfect cube in there. How many 3's go into 5? 1, with a remainder of 2. That's why this turns into x to the 1st times the remainder, which is in here, is cube root of x squared. Ding, 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 ding. All right, we're going to finish up here. Number 12. This is the best question on here, number 12. It's blank, so this is a deep breathing exercise. Okay, so we're going to all deep breathe again. So in through the nose and exhale through the mouth. I can do it. Okay, good. Okay, number 13. We're going to solve this equation here. It has a bunch of fractions in it, so we want to get all the denominators to match. So what's a common denominator between 3 and x? Does anybody know? 3x, good, nice work. So 3x, so now we get this one needs an x. over x. Yeah, I'm recording. This is for my class here. Do you want to say hi? That's Yanni. He's up for best hair high school. This next one needs a 3, and this one right here needs a 3x and 3x. Okay, so now we get all the denominators to match, and then we can just ignore them. We can forget about them. So we have 10x over 3x equals 12 over 3x plus, and then we multiply by 2, that's going to get 6x over 3x. So you get all the denominators to match, and then you don't have to worry about them anymore. You can kind of forget about them. Just forget about those denominators. So now we have 10x equals 12 plus 6x. Solve that for x. Get all the x's on one side. We have 4x equal to 12, so x equals 3. Okay, make sure that that doesn't make any denominator 0, so double check. Go back up here, check in the denominators. Does that make that denominator 0? Nope. Okay, looks like you're good. Number 14, same question, different situation here. We have in our denominators, we have like x minus 1 here, we have x minus 1 here, and we have 6 here. So what's a common denominator between 6 and x minus 1? The product of the two, 6 times x minus 1. So this one right here, these need a 6, multiplied by 6 over 6. Right here, multiply by 6 over 6. And then this last one here needs an x minus 1, so I'm going to multiply by x minus 1 over x minus 1. Okay, now let's clean all that up. Let's clean all that up. We have 6 over, and then you can just leave this, 6 times x minus 1. We actually don't really need it. Equals 6x over, should be the same denominator because that's what I just got, common denominators. And that is plus x times x minus 1 over 6 times x minus 1. Okay, the whole point of that was to get all the denominators to match. So guess what? I have all the denominators to match, so I can just go ahead and ignore them. All right, so I'm going to clean this up, create a little space here, and erase those denominators. So clean that up a little bit, distribute the x to x minus 1. This is what I have. Now this is a quadratic, so how do we solve quadratic equations? Fast Eddie, do you know that? How do we solve quadratic equations? We always set them equal to what? 0. Okay, so I need to move that 6 over here. So I'm going to move that 6 over there. What happens when I move it over? Changes signs, right? So it becomes from positive 6, it becomes over here at negative 6. Okay, so now let's clean this up. I have x squared plus 6x minus x minus 6. Do you see any redundancies in there? Anything I can combine together? Yeah, the 6x and the minus x. So that's the same as x squared plus 5x minus 6 equal to 0. You know how I'm going to solve this? Factoring. I'm going to solve it by factoring, okay? So I'm going to factor this. That's the easiest way. That's an x, that's an x. 2 factors of 6 that have a difference of 5. Plus 6 minus 1. Okay, now I got solutions here. They're going to be negative 6 and positive 1 because that's what's going to make it equal 0. All right, but I have to check to make sure that none of those make any denominator 0. Does 6 make any of my denominators 0 that have variable terms? No. But does 1 make a denominator 0? Yes. So 1 we can't use because it makes a denominator 0, and that is undefined. So what is the solution? X equals negative 6 is the only solution. All right, plugging away. Number 15, if you're still watching this, I'm amazed. X plus 1 to the 1/3 power equals 2. How do you get rid of to the 1/3 power? What's the inverse of to the 1/3 power? That's to the 3rd power. So I cube both sides. I can cube both sides. That'll get rid of to the 1/3 power. Hey, quiet down in here. I'm making a video. Come on, let's go. This is live. All right, quiet down, please. X plus 1 is equal to 8. All right. Hey, I bet you Alejandro can even do this one. X plus 1 equals 8. What's the solution? Yep. Good man. Good man. See, you could do this. I told you. So x equals 7 there. That's good. He's got it. Next question. It has a square root in it. Does anybody know how to get rid of a square root? Square it. What's the opposite of square rooting? Squaring. No, squaring. Look, how do I get rid of a square root? Well, I got to square it. Okay, so I put the 1 over to the other side. That'll get me square root of 3x plus 1 equal to, if I put that 1 over there, it's going to be subtracted 5. And then this is what I was talking about here. How do I get rid of a square root? Square it. I square both sides. If I square a square root, you know what happens? Goes away. Bye-bye. Hasta la vista, square root. So then square root's gone, so now what do I have left? 3x plus 1 is equal to, what's 5 squared? 25. Okay, solve that for x. Hey, you could probably do this one. What's the first step? Subtract 1, then you're going to get 3x equals 24. And what is x? 8, right? So put an 8 in here. Does it make it true? The square root of 25 equals 5? Good. So 8. There we go. Next question. All right. Number 17. How do I get rid of a square root? Square it. Good. Hey, you're listening. Square both sides. So go ahead and I square both sides. Square that, square that. Something amazing is going to happen here. When I square x minus 2, I'm going to get not. Warning. When you square x minus 2, you do not get x squared minus 4. You do not get that, okay? You actually get x squared minus 4x plus 4. Because you have to FOIL it out, you know? You remember you had to FOIL it out? What do you have to write it out, FOIL it out, okay? Fast Eddie knows how to do this, right? Okay, x squared minus 2x, 4. Add them together, you get x squared minus 4 plus 4. Good. All right, so you do that. And then on the left side, when you square that square root, that goes away. So that's x plus 18. Now, how do you solve? Stop. How do you solve a quadratic? Set it equal to 0. Move all that stuff over to the other side. So I'm going to move all that stuff over to the other side. We get x squared minus another x over here. I get minus a 5x minus 18. I get minus 14 like that. Set equal to 0. Hopefully I can solve that by factoring. Okay, if I can't factor, I'll have to use a quadratic formula. X and x, 2 factors of 14, that have a difference of 5. That's going to be 7 and 2. 7 and 2. This is minus, that's plus. Solutions. 7 is one of them, and negative 2 is the other one. Okay, do any of them not work? Or any of them, do they make any of them 0? Are any of them extraneous? Negative 2 right there, if I put that in there, it's going to be this, going to look like this. The square root of, let's see, 16 is equal to negative 4. Well, that's kind of true, but we're dealing with principal roots only, so they say let's just not worry about that, and let's worry about when our roots are positive only. So x equals 7 is the only solution for that one. This next one here is an inequality. You know what that means? There's a whole bunch of numbers that are going to make this true. Okay, you could look at this and see a whole bunch of numbers. What's a number that would make that true? You could probably think of a whole bunch of different ones. That's why we graph our solutions on a number line here. Okay, and then we can show it in a little picture. So like, to start, what value can x not be for the denominator? You're right, negative 4. It can't be negative 4. You know why it can't be negative 4? Because that would make the denominator 0, and dividing by 0 is undefined. It doesn't work. You can't divide something into 0 equal parts. Okay. The other solution is going to be when this is equal. So this is 2 over x plus 4 is equal to 2. When does that happen? When is that true? Okay. That's going to be true when I cross multiply. Use your cross product, set this up. 2 times x plus 4 equals 2. Okay, that's going to be 2x plus 8 equals 2. And 2x is equal to negative 6 when x is negative 3. So the other one is negative 3. So that's where your boundaries are going to be. So one's going to be over here at negative 4. One's going to be here at negative 3. So make that one negative 4, make that one negative 3. It certainly can't be negative 4 because up here, that would make your denominator 0. And it can't be negative 3 because this right here is not a less than or equal to. So now I determine if the solution is in between or on the outside. So I'm going to go ahead and I'm going to test an easy number. What's easy number to test? 0. Test 0 for x. Put 0 in there. 2 divided by 4. That's a half. Is a half less than 2? True, it is. Da, 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 da. It is. So my solution's out there. My solution is also there. Okay, what does that look like as an inequality? Well, it has a space in between, so we have to use or. It's one or the other. It's x is less than negative 4 or x is greater than negative 3. Okay, that's your solution there. Next problem, very similar. Okay, we have an inequality again. And in this one, the square root cannot be negative. So we have to decide where, like, what is that point? What is that point where, like, you're not negative, but you're not positive, you're in the middle? Zero, yeah, zero. So you're not positive, you're not negative. So, like, zero is going to be like the boundary towards going to negative. So what makes this radical stuff zero? Because you can't take the square root of a negative. Oh gosh, you're right, 2. 2 is going to make that 0. So 2 is going to be one of my boundaries down here. The other one is going to be when I solve this. So how do I solve this? Well, how do you get rid of a square root? Square it. Good. All right, so you square it. So square both sides to get rid of that square root like that. All right, square it. This side you're going to get 16. The other side, the square root went away because you squared it. We got x minus 2. So in this one, x is 18. X is 18. Yeah, right. X is 18, right? Say we got 2. We got 18. Go ahead. We put those. Those are all boundaries. 2, 18. It's okay to be 2, right? Yeah, because that we can take the square root of 0, just not a negative. And then the other one up here, well, that was less than or equal to, so this one also can be 18. Great. So now let's test a point in between or on the outside or whatever. What's an easy point to test? Well, in this case, let's check 11. What do you say, 11? Why would you want to check 11? I don't know. Why? Because I want to check 11 because this is a square root up here. And if I put 11 in there, it's going to be 11 minus 2 is 9. Okay, and so the square root of 9, which is 3, is that less than or equal to 4? You know, if I put an 11 in there, square root of that's 9, yeah. So is that 3 less than or equal to 4? It's true. Yes, it is. It's true in between there. Okay, so how do you write that as an inequality now? How do I write that as an inequality? 2 there, 18 there. Well, if it's in between, then you write the x in between. In between there, 2 and 18. Okay, that's how we do. We find our boundaries, do your test points. Next, we have some radicals to simplify. In this case, we have a cube root. Cube root of x to the 9th. Well, remember, we can split up these radicals. So we can split up denominator and numerator. That's a cube root of x to the 9th, like that. And on the bottom, that's the cube root of 8, like that. And guess what? Cube root of x to the 9th, that's a perfect cube. So that's just x cubed itself, because x cubed times x cubed times x cubed is x to the 9th. This is what we're doing right now. And the cube root of 8, that's 2. So this one actually was a nice, neat, happy little problem. It worked out nice and neat. The next one, not so much. We have the square root. Square root of 16. Yeah, that's a perfect square. Square root of x to the 5th. That's not a perfect square, but I can break it up into x to the 4th and x to the 1st. And x to the 4th is a perfect square. So now we do have some perfect squares that can pop out. 16, that's 4. Square root of x to the 4th, that's x squared. Square root of x, well, can't do anything with that. That's left over. There we go. That's the best we can do there. Okay. Let's see. Next problem. Try and make some room for this one. Only got 2 more over there. Well, hopefully I didn't miss one up there. Oh. Okay, some more radicals here. The 4th root of 2 things. I'm going to put these together. So let's go. Now we have 2 separate 4th roots, so I'm going to actually multiply and put them together. That's 16x to the 12th. Okay, because 5x's and 7x's makes 12. 16, hey, that's a perfect 4th root. That's 2. So that's going to be 2. And x to the 12th is also a perfect 4th root. That's going to be 3. X cubed, 2x cubed. How do I know that's a perfect 4th root? Because I multiply them by itself 4 times. Okay, so if I multiply all those together, 2 times 2 times 2, it's 16. X to the 3rd, x to the 3rd, x to the 3rd, that's x to the 12th. There's 12 x's. Okay, last of these radical ones here. 3 to the 5/2 divided by 3 to the 3/2. All right. So here we have some fraction powers. They have the same base, so I can follow the exponent properties, and these would be subtracted. Okay. We're doing this one right now, Fast Eddie. This is what we're doing, Yanni, in class right now. Okay, so we have 3 to the 5/2 minus 3/2 power. Okay, so this is a fractional exponent that is in a fraction, yep, but you can still do it. Okay, this is no different than doing this problem. X to the 7th over x squared. What's that? Giselle, what's this one? X to the 7th over x squared. What's that? X to the, come on, we're doing this right now. X to the 5th. Good, Michelle got it. Oh, haka, nice job. All right, same thing here. It's the same thing here, but we're doing 3 to the fractional power. So 5 halves minus 3 halves. What is that? That's 2 halves. 2 halves is 1. That's just 3. All that is just 3. That whole thing is just 3. Pretty crazy. All right, next are the most fun word problems. Okay. All right, we're talking about boats. Okay. A boat can travel 8 miles an hour in still water. If it can travel 15 miles downstream in the same amount of time it can travel 9 miles upstream, what's the rate of the current? Well, that's my variable then, because it's asking what's the rate of the current. So C is equal to current, rate or speed. Okay. Well, there's a big word in here. There's a big word in here. It was the same. If we look back, I have it zoomed in a little bit, but if you look at it, in the same time. Okay, same. What does that mean? What does the word same mean in math? Equals. It means equals. Good. So some stuff is equal. What stuff is equal, you say? What stuff? Well, the stuff that's equal is the time. It's the time upstream and it's the time downstream. Okay, well, what do you mean by time? It doesn't tell us the time. Well, it doesn't tell us the time, but time is, we have been using this distance equals rate times time formula, and if I solve that for t, time is equal to the distance divided by the rate. That means if you went to Duluth and it's 160 miles to Duluth and you're going 80 miles an hour, then how many hours is it going to take you to get there? 160 miles divided by 80, 2 hours. Okay, that's how it all works. You should be doing that in the car when you go on road trips. Okay, 400 miles to get there. We're going 80 miles an hour. Oh, that's going to be about 5 hours. That's not too bad. I'm going to take a nap. All right, so now we have time. So, distance over rate. Well, one of them went 15 miles. That's the one that went downstream because it's going faster downstream because you're going with the current. The other one went 9 miles upstream. It's harder to go upstream because you're fighting that current, right? Okay, how fast is the boat in still water? Well, that's 8 miles an hour. So downstream, I'm 8 plus the current, and upstream, I'm 8 minus the current. So there's your relationship between the two. All right, I'll let you solve the rest of that because this video is getting a little long, but you use your cross products, take those, set those equal to those. Okay, and I believe, don't quote me on this, you can correct me in class if I'm wrong, I believe that the current was 2 miles per hour. I don't know. We'll just double check. Double check with me if I'm wrong. Okay. Last question. Passenger train travels. Passenger train travels 20 miles an hour faster than a freight train. It's going faster. If a passenger train can cover 200 miles in the same, what does that mean? Equals in the same time. So the time is equal again as a freight train. This problem is very similar to the last one. So how fast is each train? So we'll say X is the speed of, let's just say the slower one, the freight train. So X is the freight speed. Okay, well then we got to have because it said that the time was the same again, so we have the time of the freight train and the time of the passenger train. Okay, and we know the distance of each one of them. The freight train went less far, so the other one went farther. So the passenger train went 200 miles. The freight train went 150 miles. Now we need to know how fast it was going. Well, one of them was going 20 miles an hour faster than the other. That's all we know. So if the freight train is X fast, the other one is X plus 20 fast. There we go. Have that set up again. There's our equation. That's how the two are related. Use your cross products, set those equal, solve away. 200x is equal to 150x plus you got to distribute that 150, right? So that's going to be 150 times 20, that's 3,000. Okay, subtract the 50 from the other side. I'm going to get 50x is equal to 3,000. So that's going to be 60 miles an hour. 60 miles per hour for the freight train. And the passenger train was 20 faster, so that's going to be 80 miles per hour. All right, that concludes the practice test key. Congratulations, you're a good student.